We're very pleased today to welcome Dr. Samantha Morrison from Wits University. Dr. Morrison started teaching in 1993 and enjoyed a successful teaching career for 19 years before focusing on teacher education. She received her B.Ed honors with distinction at Wits University in 2012 as a part-time student, which opened the door for her to do her master's and PhD full-time as a member of the Wits-MathS Connect primary project under the leadership of Professor Hamsa Venkat. She received her Master's in Education in 2013 and her PhD in 2018. And Samantha's doctoral work focused on the remediation of early number learning at grade 2 level. She then went on to complete a 2-year postdoctoral fellowship under the tutelage of Professor Mike Askew and took on a managerial role at the Wits-MathS Connect primary project. So for the past 9 years, he's enjoyed working in the field of primary mathematics education alongside collaborators from diverse backgrounds who share a common goal, which is improving mathematics teaching and learning on the ground. As a young researcher, Dr. Morrison has recently started publishing articles and conference papers and is currently focused on training primary math subject advisors in different provinces as a way of scaling up project-based interventions that have shown promise over the past 10 years. She's presenting with us today under our focus area of mathematics education research. And today she will be presenting a seminar on her work on a multiplicative reasoning intervention in grade 2. So at this point, I'd like to hand over to Dr. Morrison. And please do kick us off. Thank you.
Thank you, Diane. Good morning, everybody. It really is a pleasure for me to be sharing some of my work with you. I hope that you'll find it interesting, and I hope that it may spark some interesting conversation that we can have afterwards, and that it would maybe ignite something in you for you to either do new research or just carry on with the exciting work that you are doing right now. And as Diane had said, so I done a multiplicative reasoning intervention in grade 2. Okay, so just a little bit of background. This intervention was actually a second iteration of an intervention that we had carried out with Gauteng subject advisors. Okay, so let's start. So here I report on findings from this study, as I said, through upskilling foundation phase subject advisors. And we know that this is done in a South African context where low learner attainment in number is widespread. So the biggest problem we have on the ground in the foundation phase is that learners count in ones, okay? They sometimes use their fingers, sometimes they use counters, but that is the biggest problem that we have, and this problem persists into the upper primary grades. And you can imagine with every consecutive year, the number range increases. So for example, by the end of grade 3, learners should be working up to 1,000. And then from grade 4, we go into tens of thousands and hundreds of thousands. And for children to be counting in ones, it's just absolutely impossible. And that is why we've been getting such low learner attainment. Now, I want to just show you something from Hoadley's work. So the picture on the left is taken from Hoadley's work in 2007, and on the right from Scholar's work. And we see that there's an example of a grade 3 learner trying to solve a number problem that is in the hundreds, by drawing circles. So we call this either unit counting or tally counting or counting in ones. And from Scholar's work in grade 5, I'm so sorry, I don't have the example that it was, but it was also way into the hundreds. A grade 5 learner trying to solve a number problem by counting in ones. So the counting in ones is a pervasive problem that we know. We also know that South African learners struggle with word problems and situations that call for multiplicative reasoning. Okay, so all of this was taken into account when we developed an intervention strategy. So I'm now going to talk a bit about multiplicative reasoning because that is, I think, the main thing about this intervention. And the way we approach multiplicative reasoning in our project is we see it as a conceptual field, okay? Meaning that multiplication and division, these two operations are not seen as completely distinct and separate, but we see them as being two parts of one whole, okay? Now we know from literature, but I'm sure many of you, I know I can surely testify that at school, adding and subtracting was okay. As soon as they brought in the multiplication and the division, that's when things went just downhill. And we find from literature as well, we know that multiplication and division are problematic from a teaching perspective and from a learning perspective. Now, multiplicative reasoning, and please, when I say multiplicative reasoning, I'm speaking about multiplication and division, okay? It is important because this type of reasoning underpins the future topics, the future learning, okay? For example, ratio, proportion, Cartesian products, percentage, there's so much, actually a lot of what children encounter in their secondary maths, even in their tertiary maths, it is premised on an understanding of multiplicative reasoning. So this is really important for learners to kind of get under the belt. Now, using Vernard's distinction, Prof. Askew also sees the difference between additive reasoning. So if I say additive reasoning, I'm speaking about addition and subtraction. So he sees a difference between the AR and the MR. Additive problems are ternary. That means they involve 3 numbers. Whereas multiplicative problems are quaternary. That means they involve 4 numbers, with a hidden number being 1. Now I'm going to show you in my next slide what I'm talking about. Okay, so here I've got a problem. I put apples into bags. I put 6 apples into a bag. I add 8 more apples to the bag. How many apples are in the bag altogether? So we see the problem deals with apples and bags. We see there's a number 6 and there's a number 8. And the question is how many bags altogether? My next problem, I put apples into bags. I put 6 apples into each bag. I fill 8 bags. How many apples are in the bags altogether? Again, here we've got a problem with apples in bags. We see the number 6, we see the number 8, and the question is how many apples are in the bag altogether? But what you'll see that in the first problem, which is an additive situation, there is one variable that can change, and that is the number of apples, okay? In my second problem, which is a multiplicative situation, there are 2 variables that can change, and that is the apples and the bags, okay? And this is, it's subtle, sometimes it's nuanced, and many times even the teachers themselves kind of don't catch onto this distinct difference between an additive problem and a multiplicative problem. So in our example, to solve the additive problem, I add 6 and 8 and I get 14 apples. And to solve the multiplicative problem, I will say 6 times 8 and I get 48 apples, okay? Now, I'm going to draw your attention to another distinct difference, which actually links to this hidden number. In the additive problem, we'll see that 6 apples were put into a bag, okay? But in the multiplicative problem, 6 apples are put into each bag. Hold that in mind, and I'm going to talk to that in a minute. Now, Greer, and I know there are many other researchers too, they argue against merely seeing multiplication as repeated addition and division as repeated subtraction, because these are very limiting views of complex situations. The subtle ratio that is invoked in multiplicative problems is what makes them distinct from additive problems. It's that ratio. Now, remember a bag and each bag. Now, that word each, that was the hidden number 1. In other problems, they'll say per bag or per car or whatever. So it's implicit many times, but there is a ratio that is involved in a multiplicative situation that is not involved in an additive. And you see, this is complex, but for many educators, and certainly, as we'll see, for how our CAPS document introduces multiplication just as an extension of addition, that is a very limiting view. And we found that by seeing multiplication and division as a conceptual field rather than as distinct operations, this actually helps learners in their conceptual understanding. So what I did here is I just went to go and screen grab the headings for the overview of topics in the CAPS curriculum from page 21 and page 22, just to show you that they actually repeated addition leading to multiplication. I mean, that, and it's stated so many times in so many places. And what I don't cover here are the different semantic structures in multiplicative problems, okay? And these are important because it influences how the child will go about solving a problem. So a semantic structure could just be a plain ratio. Sometimes there's an array. If they talk about a farmer planting so many apple trees in a row and planting so many rows of trees, and how many trees are they all together? Because of time, I don't cover it here. But even that is an important point to take note of when you introduce multiplication and how you extend the concept, and obviously for division, because so I knew growing up that to divide means to share, okay? But to divide can also mean to group. So the semantic structure, even in a division problem, will influence how children solve it. As I said, I don't have time for that there. What I want to talk about is models and modeling. Now, this was also an important aspect of the intervention. Okay, so let me just first say models, they're described in different ways. And I'm sure if you're a researcher or a practitioner or a student, you know that so-and-so will say this and so-and-so will say that. And you know what, in the end, you know, we can't say anything is wrong or right, but we just mention all of them. So I've mentioned a few ways that models are described. So it can be described as an image that's acted upon or that stands in for something else. So when children draw those tallies, those circles or those little lines, okay, those little lines, that is something that stands in for, whether it's apples or whether it's sweets or whatever is being spoken about in the problem. And so it represents the problem. Now, what modeling is, it's the process, you know, that the child or that the person will go through as they try to make this situation that is maybe abstract, it's a story, they try and draw it or they try and represent it just to make it more real, okay? So modeling and models are important because they can assist both the teacher and the learner in making this abstract concept more real or more critical, okay? Sorry, more real or more concrete, okay? So models, models have been described also as a bridge, okay, as a bridge. So while the child is like maybe grappling maybe with counters, sometimes they working with concrete objects, they can then draw the counters just as a step away from the very concrete. And then maybe later they can only work with the symbolic numbers. Okay, so in that way, there's a transition from how the child works with the problem. So I'm going to talk very quickly about 3 models. That and everything obviously that I say is research based, but also it is how we approach this intervention. So I'm going to talk about arrays, the double number bar, and a table model, or the table, also known as a ratio table. Why I talk about all 3, even though you will see only one was kind of foregrounded or used in our intervention, I speak of all 3 because there is a link. Nothing ever stands on its own, obviously, because from the array model that can progress to the double number bar and then to the t-table and so forth. And this that I'm reporting on was what was done in grade 2. But if you go onto the maths, the Wits Maths Connect website, you'll see that we've got multiplicative reasoning for grade 2, 3, 4, and 5. So even though the other models don't come into play in grade 2, they certainly do in the higher grades. Okay, so let me talk about arrays quickly. So we know arrays, it is it's almost like an area model with the same amount of dots in rows and columns, okay? And many researchers have argued for this powerful image because they believe this can really show or really introduce learners to the 2-dimensional nature or the 2-variable structure of multiplicative situations. The array on the top shows 3 times 5, which is equal to 15. And at the bottom, 5 times 3, which is also equal to 15. So as children learn more about the multiplication operation, they do get to know that multiplication is commutative, okay? Now, what is nice about an array is if I was holding the array for 3 times 5 like this, and I'm showing learners, oh, wow, look, there are 3 rows and there are 5 columns, and altogether there are 15. If I turn the array to show a different orientation now where there are 3 columns and 5 rows, and the total number is still 15, just being able to show different orientations of the same thing, it's very powerful for children to see the commutativity, that it's the same number, we've done nothing different, we're just looking at it from a different perspective. And I can tell you that when we done this work with the Gauteng subject advisors in 2018 and 2019, the one subject advisor was like, wow, I just never thought of this, that there can be one representation to show both input numbers and the total, okay? Now, that is part of the power of this array image. We do know that as children progress and use a higher number range, the area model is also a powerful model to use, and that grows out of the array model. The double number bar shows all the possible ratio pairs, and it's usually presented horizontally, okay? So the double number bar shows the number of bags from 1 to 8 and the number of apples from 6 to 48. I'm so sorry, it seems like my numbers are slightly too much to the left, okay? Or to the right, sorry. So from the double number bar, I can read off that in one bag, there are 6 apples. In 2 bags, there are 12 apples, okay?
Dat is aardig.
The the disadvantage of the double number bar is that to work out how many apples in 20 bags, you kind of have to, draw every ratio pair. After 8 bags, then you must draw for 9 bags, 10 bags, up to 20 bags. So that can be time consuming, but it's an important step for young learners, okay, who are learning to use and to think multi-applicatively. So this is normally a precursor to the ratio table. I've got an example there. Okay. It shows 1 bag, 6 apples, 2 bags, 12 apples, then 4 bags, 24 apples, and 8 bags, 48 apples. So what is happening here? We see that the calculations or let's say the ratio pairs are 4 lines, and I could get to 8 apples. So this means that with the T table, you have more flexibility. So as learners become more confident working with doubles, working with multiples of 10, and so forth, they can, if they had to find, let's say, 20 apples, and they knew that in 1 bag there are 6 apples, well, in 10 bags, there's going to be 60. And then I can double that to find 20 bags. Whereas if you only use the double number bar, you would have to, put in every ratio pair. So what is nice also about the T table is that it makes the scalar relationship within the quantities very visible. So for example, I can see from 1 to 2, okay, I doubled that. From 2 to 4, oh, I doubled that. And to go from 4 to 8, I double. So this was clearly someone using doubling, okay, which is also a strategy that children learn in their multiplicative reasoning. And then as you look across the columns from 1 to 6, 2 to 12, 4 to 24, there we see the constant ratio, okay. And I tell you something, we done this intervention, as I said, in fact, we went up to grade 7 with certain schools. But I remember working with a grade 5 class in an ex-Model C school that served previously disadvantaged learners. And they caught onto this so quickly. We didn't only use the T table like for multiplication, but also for division, and they were just able to just work flexibly with this. And it was lovely just to see the quick take up of something that some people find, oh gosh, will the children be able to grasp this? Won't it be past them? Actually, I think, when we work with kids, we see more times than not that they are able to do actually more than what we expect them to do. Now, I want to speak now specifically about the second iteration of this project. Okay, so this was the project that I led, and it was a project that we went to lead in another province, because the first iteration in Gauteng went very well. The children improved in their multiplicative reasoning, because we had a pre-test and a post-test, and we compared the mean scores, and it was great. But something else about the Gauteng province is that as a project, and having worked for 10 years in this province, we have had a lot of interaction with the subject advisors. Okay, they have come for content courses, they have done many things. So we had a lot of interaction with them. There was a good sense of camaraderie and collegiality. They could contact us for any challenge that they were experiencing. So over the years, we developed quite a lovely working relationship, and there was obviously great take up and enthusiasm, because we were now one step removed from the schools in that we weren't training the educators directly, but we were training the subject advisors, and the subject advisor had to go train the teacher in the class. So we wanted to see whether another group of subject advisors who we didn't know, who we would only have minimal contact with, okay, if they could, implement the same project or intervention, and if they could get similar results. Now, all they would have to rely on would be the materials, okay? Not that we wouldn't have any contact with them, but obviously our contact would be minimal. So we wanted to understand whether by helping learners to construct models for multiplicative problems and only using a 4-lesson intervention, we wanted to know, can we see any change? So what we did is we worked with 16 foundation phase subject advisors in a province. I can't mention the province right now, unfortunately, because there's been a slight hiccup in terms of our ethics, which should be sorted out by the end of this week. So for safety's sake, I will not include the province's name. And when I mention a school later, I will use a pseudonym. And when things change on the ground, when I get the tick in terms of that ethical clearance, then I will certainly update this with Diane, and because I know she will in a couple of weeks' time or so make this, either the slides or the presentation available. So that will happen. Okay. All I can say is that this is a South African province where the cohort of learners have historically, they've consistently performed poorer than Gauteng learners, okay? The field where we worked were 35 grade 2 classes, and there were 15 schools, and the lot in these schools were Setswana. So if you know your vernacular languages and which languages are prevalent in which provinces, you could work this out yourself. All I can say is that what needed to happen was all our material had to be translated. And I'm very glad to say that the subject advisors in this province themselves actually helped us with this process. So here, I'm going to show you the intervention model. So I hope you can see my cursor moving. I think you can, okay? So this year, AM shows for in the morning, PM for in the afternoon, and these are just additional notes. So what you see across here, there's 1, 2, 3, 4, 5, 6, 7, there are 8 columns because this intervention only runs over 8 weeks, okay? Here, there's nothing that happens in the morning, and in the morning means at school, okay? Nothing happens at school, but the WITS Maths Connect team have a pre-intervention session with the subject advisors, and that normally lasts for 3 hours. In that session, we talk about how to approach this multiplicative reasoning topic and the rationale for that. We explain how the materials work. We hand each subject advisor, her materials for herself, and we give her the materials for every educator that she's working with, so they could choose 2 schools or 3 schools, okay? And then we also give the materials for every child in that grade 2 classes. So trust me when I say, when we rock up to that first meeting, it's almost like we need a Fenta trailer, but we give them everything that they would possibly need, so that when they kick off the following week, in week 1, the subject advisors themselves run a pre-test with the grade 2 classes. I must say something about the pre-test. The pre and the post test is actually a repeat test, okay? I've got some slides later just to give you an idea of what the test looks like. Before subject advisors obviously go into schools or select schools, they have to approach the school, see which school is willing. When the principal, is willing, then you must talk to the, either the grade head and then every educator, and you get buy-in from them. They would then explain what the project entails and all of that. And once all the ethical stuff is sorted, the principal has signed, the educators, the parents, the learners, then everything kicks off, which is now in week 1. So after the pre-test is run in the morning, subject advisor doesn't leave school, but sits at the school and waits until the grade 2s have finished. Then in the afternoon, here you can see mark scripts with teachers. Now, they don't get to mark all the scripts, okay? But every grade 2 ma'am will mark a few of her scripts, while the subject advisor also marks a few. And then after about 10 or 15 minutes, they'll stop marking. Then they'll talk about what they're finding, okay? Oh, I see, oh, all my kids that I've marked so far, maybe they all got question 1 right, and maybe all got question 2 wrong, or I'm seeing that my children did this or my children did that. So then they just chat through that. After that, subject advisor will reflect and plan for lesson 1. So in that week, there was no lesson given. Let's say the school said that the subject advisor could come in every Tuesday. So on that Tuesday, there was no lesson given. In the morning, only the pre-test was run. In the afternoon, they did some marking. And within that week, you'll see here under in notes, the subject advisors will email that spreadsheet with the mark lists to myself, okay? I will then have a look at them, and then with the team, we'll do our own discussion and all of that. The following week, Tuesday, the subject advisor will observe and or coach lesson 1 with the grade 2 educators. So if she is with ma'am, let's say ma'am number 1 from 7:30 to 8:30, then she'll be with ma'am number 2 from 8:30 to 9:30. Maybe after break, she'll be with the third class if there was a third class, okay? But the lesson wouldn't be taught unless subject advisor is there, because subject advisor must observe and coach. Later in the same afternoon, they will meet again, reflect on how the lessons went, what you think went well, what you think didn't go well, and based on that, they would then plan for lessons 2 and lessons 3. Okay. In the next week, let's say it was a Tuesday or whatever, here the grade 2 educator will teach lesson 2 on her own. The subject advisor will not be in school. So we see that so far the subject advisor was in school on that day and but not in this week. In the afternoon, the WITS Maths Connect team will then drive to the province, and we have scheduled a meeting for 2 hours. Also, we reflect, we talk about what has worked well, what hasn't worked so well, and we also, we just try to iron out, whatever problems may have arisen and things like that. In the next week, subject advisor is back at school to observe and coach lesson 3. Afterwards, they have the same planning meeting. Week 5, subject advisors are not in school, but the teacher will teach the 4th lesson on her own. Week 6, subject advisor is in school to run the post-test with the grade 2 classes. Afterwards, she will meet again to mark a few scripts and then have a reflection meeting. And because this project is actually going to happen over 3 years, they talk about, how to improve things, how to change things. And you know what, this year we're actually going in and we're going to change the topic from multiplicative reasoning. We're actually going to do, I think we're going to do base 10 thinking. So all of those kind of things happen there. And by the end of that week, I then again got a spreadsheet with the post-test marks for all the learners, okay? In this last week here's now where we've got all the pre-test marks and the post-test marks. We've compared them. Here's where we have all the learner scripts from the pre and the post-test. We have all our feedback notes that happened as the subject advisor met with the educators. And this is where we now sum up what happened, pre-test, what happened post-test, were there any learning gains, and how those gains looked. Okay. Oh yes, here I've got just an example of the English version. Okay, it's the first page. So for example, question 1 was, on Thursday, Lerato picked 17 apples. On Friday, Lerato picked 13 apples. How many apples did Lerato pick altogether? They can, if they want to now, learners are told that they can make a drawing if they want to, but they don't need to. If they just know the answer, they can also just write the answer down, okay? So those were questions from the first page. From the last page, question 10, Hamza is taking 30 eggs to the shop. She puts the eggs into egg boxes. Each box can hold 6 eggs. How many boxes does Hamza need? And then they can either make a drawing, or they can just write the answer, or both. Question 11, 12, 13, and 14 are what we call whole number calculations. Bold, because I know bold means you have no hair, but here bold just means it's only numbers. Some people also say bare number, okay? So 11 is 17 plus 13, 12, 25 minus 18, 13 is 5 times 3, 14 is 24 divided by 4. Now, I'm sure you're wondering, she said it was a multiplicative reasoning intervention. Why are there addition and subtraction questions? I'm glad that you thought that question, okay? What we found in our years of working was that if we focus on a particular topic or, a type of question, the learners soon get onto the idea is, oh, this is what they're checking. So the test was made up of 14 items. Of the 14 items, 10 items were multiplicative. Okay, that means 10 items was dealt with multiplication or division. So there were 4 items interspersed in between the 10 that did not deal with multiplication or division. And this was thrown in just so that learners wouldn't be cued into doing a multiplication every time. They had to read and think about what the problem was about and then work. What was also nice is that the additive problems that we put in, okay, they were linked, meaning that, so if you look at, for example, number one is a word problem. To solve that problem, we would basically say 17 plus 13. Now, if you look at number 11, no, that is now a bare number task or a bold number calculation, but it is essentially the same thing. There it's in word, here it's bare number. So we also linked certain word problems and bare number problems for the multiplicative questions. For example, look at number 2. Look at the spot 3 legs and 5 legs on each. So there we want to either say 3 times 5 or 5 times 3. Now look at number 13. Also 5 times 3. So these 2 problems are linked. Okay. So we have 4 such problems. 2 for the additive and then 2 for the multiplicative reasoning. I'm going to talk to that later, so just bear it in mind. results. Okay, how am I doing for time? Okay, I see I'm still, okay. Let me do this. Okay, so you'll see on this first table here, for the test, all 14 items, okay, we had matched data for 1,454 learners. Obviously, there were many more learners who wrote the test, but of those who were there for the pre-test, didn't come for the post-test. Others were absent for the pre-test, but they came for the post-test. So we only had matched data for 1,454. The mean percentage for the pre-test was 24.7. The mean score, the mean score for the post-test was 42.6. And we see there that the difference was 18%. Now I'm going to talk about the matched word problems. And these are the multiplicative problems. Remember, two word problems were matched to two bold number calculations, okay? Again, same number who wrote, 32% for the pre-test and 48.5 for the post-test, and we see a difference of 16.5. And then for the matched bold calculations, 21% for the pre-test, 40% for the post-test, and a difference of 19%. So we see that the learners in each case improved across the pre and the post tests. What's also interesting to note, why I've got these in yellow, is that the word problems and the bold calculations in the pre-test, 32% for the word and 21% for the bold. So there was a difference of 11%. Learners performed better in the word problems than in the matched bold calculations. Same in the post-test. They performed better for the word problems, okay, even though, even when that same problem was just shown as a number problem, okay. So even though it dropped a little bit from 11 to 8.5, we see that's not much difference. Learners consistently perform better in the word problem. Now, looking for the significance, okay, of the difference using the t-test and SPSS software. Oh Lord, I keep doing that. Okay, sorry. As we said, for the pre-test, 24.7 was the mean. The post-test was 42.6. The t-value was 27.41. Now this is significant because it is way more than the 1.64. Okay, so we know that there was a significant difference between the learner performance for the pre and the post. Same for the matched word problems. Okay, 16.35, way more than 1.64. And the same for the matched bold calculations. So the t-test analysis was carried out at 95% confidence level. Okay, and so we are, how can I say, very confident that the differences, you know, was significant. What we didn't do, unfortunately, was a delayed post-test. It wasn't in the initial plan, but it is something that I know Prof. Askew had done with a previous study that he ran, but I'll explain later what happened in the midst of all this. So that was the quantitative analysis. For the qualitative analysis, here I wanted to look specifically at the models that learners used, okay? So I just want to give you an example of how this was coded. For example, here by number A, it is that story about the 5 pots, and each pot has 3 legs. Here we see a child drew 3 tallies and a circle, 3 tallies. So every 3 tallies are circled. And this is an example of structured tallies because the structure is evident in the circles drawn or in the number of tallies. So that's 3, 3, 3, 3, 3, okay? In B, this is an example of an array model. So, right? So the same number of circles in each row and the same number in each column. Hereby C, this is an example of deleted tallies. It looks like the child drew 25 tallies and then scratched out 18 of those tallies. This was coded just as unstructured tallies. There is no circle drawn around any of them to show any kind of structure. There's nothing being scratched out, so it can't be that the child took anything away. In fact, we don't know what the child done here. All we know is what we see, and that is tallies, and there seems to be no structure. This last one here, E, was coded as an iconic model because those little drawings actually looks like, you know, if you open a half dozen count carton of eggs, you'd actually see them looking like that. So it was a very realistic picture. Okay, I'll just go to the next slide. What I'm showing you here is on the, so this is the pre-test, that's the post-test, okay? Pre-test, that is per item, and that is the number of models per item. The first 3 lines, well, that's when there were no models. Then there was tallies, structured, unstructured, and whatever. I just want to show you this here, that in the pre-test, the highest frequency was for no representation with an incorrect answer. And in the post-test, it was the highest was for structured tallies. Okay. And the conclusion you can just maybe read on your own.
So guys, I'd like to invite our audience now to please come forward with questions or comments that you might have. Like I said, you can raise your hand or you can just unmute your microphone and go ahead. Hi, Mamodise, do you want to go ahead?
Okay, yes, I wanted to find out what is the purpose of the pre and the post tests.
Okay, the purpose of the pre and the post test is to analyze the impact of the intervention. So what we do is we give a test before learners do any lessons. Then we do the 4 lessons, 1 lesson every week. Then the next week we do a post test to compare what the learners done on the test before those lessons and what they done after. So we compare it and then we see if there were any learning gains.
Okay. But do you have the situation whereby learners would be on the same level during pre-test and post-test?
Yes. So what the values and the scores I've given you are the mean, it's the average scores. You certainly have learners who do the same on the pre and, you know, or on the post that they got on the pre. You even can have learners who did better on the pre and did worse on the post. But for what we see is the mean, or it's the average. It means overall, more children did better on the post-test than they did on the pre-test.
Thank you.
Thank you, ma'am.
Excellent, thank you. Philip Southey, you've got your hand raised. Would you like to come forward?
Thanks very much. Samantha, thank you for a wonderful presentation. This makes me so excited. I teach physics at Stellenbosch University, so I'm currently teaching 800 engineers.
Oh.
And I'm introducing them to what I call the ratio table, which I thought I had invented. So it's wonderful to get these references. Obviously, my research is in tertiary physics education. So I was unaware of Striefland and Berg now. I'm going to look those up. Thank you very much. For us, it's the units especially. So if you say, for example, 5 meters per second,
Yes.
that M per S, many students just, you know, it's sort of like writing a squiggle M/S. There's no idea that it's 5 meters is to 1 second.
Yes.
And then obviously we're teaching far more complicated units like joules per second per square meter for intensity and so forth.
Yes.
And then for algebra as well, we found it very, very useful. So to say, you know, how far will it travel in X seconds,
Yes.
and so forth, and then still using that table. So I'd love to chat further.
Yes.
Thank you so much for the inspiration. My question is, sorry, just to go back to the previous slide, I didn't quite get in the qualitative data. Did you say that the students that had drawn the diagrams did worse in the post test? They were more likely to get it incorrect?
No, no.
Okay.
No, so I'm just showing that previous slide. All I said was in the pre-test, most of them, this 47,3, that shows that was the majority of them had no representation with the wrong answer. Okay. Here we just see that the representation used was structured tallies. Now, some people might say, oh, hold on, but your intervention there was not successful because we foregrounded the array model. And you'll see arrays right at the bottom here, 25,9, okay?
Mm-hmm.
But we said, no, we still find it to be great because that very first slide where I showed you how they were drawing those tallies and the circles, you know, we found that this group moved away from that tally or counting in ones. They actually drew more structured tallies. Now, one caveat about these figures here is that I didn't only count models used when the answers were correct. I counted all models used. So what we done is we said the pre-test, there were less models. So you can see this number here, 298 were the number of models used in the pre-test, and 1,202 were the number of models used in the post-test. So we're saying less models used here, more models used there. Here they had a lower number of correct answers, and here they had a higher number of correct answers. So we know that correlation doesn't just automatically mean causation, but because literature says that models help them to understand better, we interpreting it as the higher number of correct answers is actually linked to the higher number of models used. I don't know if that makes sense.
No, Samantha, thanks very much. That would have been my intuition. That's why I was a bit surprised when I interpreted it as it was the highest frequency of incorrect answers. So that makes a lot more sense to me. Thanks.
Oh, thank you.
And just to reiterate, yeah, I'd be fascinated to see if you guys ever find an overlap with physics teachers at junior school who are playing around with units. I really think there's an exciting opportunity there. But like I said, I'll send you an email.
Thank you. Thank you very much.
Thanks again, Samantha. So.
Okay.
Yeah, and thank you, Philip, for the question. Samantha, sorry, it's Diane. Let me put my video on. I'm kind of desperate to ask a question. Is that okay? You don't mind?
Yeah, I don't mind.
So just to give you some context, I study within linguistics. Okay. So particularly psycholinguistics related to interventions and teaching interventions. And I've spent a lot of time with sort of English teachers doing training workshops and stuff like that.
Yeah.
And you mentioned, it was just interesting because you mentioned semantic structures earlier, which I realize is within a mathematical context.
Yeah.
But within linguistics, we also refer to semantics, you know, in terms of meaning. Yes. This might be an awkward question, so I'm sorry if it is, but I just thought it was so interesting. You know, one of the things that I was thinking the whole time is, has there been, that you know of, or maybe you guys consider it, sort of the role of language and language knowledge within this? One of your very first examples was talking about putting apples in bags. Yes. And I was thinking, like, does that not then rely on the learner understanding the difference between each and the bag or each bag.
Yes.
Is there a consideration there within your study or studies that you know of?
Yes. So language is very important. In fact, there are many studies, and I'm sure you've, the VC of UCT, Mamogeti King. I don't know am I using her old surname or her married surname? She's written a lot on language in maths.
Okay.
Also, I don't know, have you heard of Joel Adler, who works?
Yes, absolutely. Yeah.
She writes a lot of language in maths. The head of Marang, Prof. Tony Essien. So language plays a huge role, okay? And it's one of my pet peeves, actually, because, when I was in master's, and I think Dr. Tony was at the time, he was doing that course. And, the demographics in our country meant that I was like the only colored person there. There was like maybe one other Indian person or white person, but the majority was, Black people who speak a vernacular, okay? Dr. Tony says it has been proven that it's best for children to learn in their home language,
Sure.
when they're in the foundation phase, and blah, 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 blah. So I put up my hand and I said, excuse me, sir, do your children go to a school where they learn in the vernacular? Because I just saw his one daughter who at the time looked like she was in the foundation phase. And he says, we're not talking about me right now. I said, okay. If you allow me, can I ask the class, how many people here have put their children into a school where they were taught in the vernacular in grade 1, 2, 3? And no one put up their hand.
Wow, okay.
Right. Now you're telling me that research has shown that it's the best thing. And as a parent myself of 3 kids, I will want the best thing for my child. Why is nobody putting their child into, and obviously it was a huge debate, and Prof. Tony actually wrote an article a few months later, which I just happened upon as I was searching something on the internet, and he then answers that question, and he says, I had a student ask me this, I didn't know how to answer it at the time. Upon reflection, this is why. And his answer in a nutshell was that many of the vernacular languages haven't been developed to the point where mathematical and scientific terms, actually exist in the language.
Yeah.
Okay, so now here comes my problem, right? Because as I said to you, I taught for 19 years before going into teacher education. And I said, right, now what does the teacher on the ground do? Because we also know many kids go to English-speaking schools when their home language is Zulu or Setswana. And then, so this was the thing, because a bag and each bag, for me as a first language speaker, I don't even give it much thought. But for that child in your class, you have to make such distinctions. You have to shine a lot of light on it. Now the teacher needs to have that pedagogical content knowledge, kind of, or specific content knowledge. I don't know which it would be. She should know that this is potentially a problem for my learners, because they don't, a bag and each bag to them might just be the same thing. Or if I say a car or per car, it's different. And so what you're saying is absolutely, that is so critical. That is so critical, that if the language isn't made clear, our children can't access. And so I know for a lot of like what is happening now, it's trans-languaging, or they call it code switching.
Yes.
Yeah. And if I say to you, divide 12 into 3s, and I say to you, divide 12 into three groups. It sounds like the same thing, but one will have an answer of 4 and one will have an answer of 3.
Yeah. Yeah.
So, and you know what, the other unfortunate thing is that for many of our educators, they actually have to teach in English when English isn't their first language.
Yeah.
So there are certain nuances and subtleties that even they miss, and one can't fault them, really.
Yeah. It was quite interesting. On a later slide, you had the 5 examples of the problems, and they were obviously written in, I'm not sure, you said it was Sesotho or Setswana, I think.
Yeah.
And I was, and it occurred to me that even in their first language, that there's this literacy requirement. So thank you. Sorry, I'm not gonna keep you much longer on this question, but thank you so much, because it's lovely for me to see,
right?
you know, as someone.
Yeah.
Yeah, no, just as someone who works within the mathematical academic sort of circle, but also as a linguist, it's lovely to see and hear about that crossover. So thank you very much. And I will stop there.
We're also very mindful of the fact that at grade 2, children, you know, we know that our reading levels across our country, especially in, like, you know, our lower quintile schools, children's reading is also poor. So how the test is run is that the subject advisor has to read every question with the learners twice out loud. And then like learners are like given time about 2 minutes to solve each question.
Okay, so very similar to linguistic studies, to be honest. A lot of the intervention tests are done orally, so that's very interesting. Thank you. Okay, everyone. Philip's raised his hand again. Are you happy, Samantha, to take another question?
That's fine.
Great, Philip. Thanks.
I can't resist myself. Sorry, it's just from your question as well, just to speak about the relationship between the language and the language understanding and the conceptual understanding, and whether you draw a line between those. So, for example, in physics, if we're speaking about force, we don't want students just to think that force is the F in the equation, F is equal to ma, for example. And when you see the word force in a problem, you just stick that number into the F. We want them to relate it to, like pushing and pulling on a playground. So, for example, in Afrikaans, you want that relationship to stoot, you know, extoot. But I'm not sure whether linguists would make that cut and dry distinction between a linguistic understanding and a conceptual understanding. So we're wanting to ground that word in their underlying conceptual understanding. I don't know if I'm making any sense. Just for me, that distinction between, so for example, a word like per, there might not be the conceptual grounding. So even if you were to say the word in Afrikaans or in Xhosa or in Tswana, like there's no conceptual grounding on which the words land. So it doesn't make a difference if you're using the home language in that case. So this is a whole nother topic. Thanks.
Okay, great. Thanks, Philip. I kind of agree with Philip. There's like a whole other ball game opening here. It's quite interesting, but it's lovely. It's what we do strive for, this kind of interdisciplinarity, you know. So
yes. And can I just say something, or do you have another question?
I don't have anyone waiting with a question. No.
Okay, great. So you know, I just want to come in on what Philip has said. Linking with the, you know, the linguistic, and you know, so for example, I think many of us were taught in school that to multiply any number by 10, you just add a 0. Have you heard that? I'm sure you've heard that, right? And we know conceptually that is false, okay? Because if I had like 0.5 or a half or a quarter, and I wanted to multiply it by 10, I can't just add a 0, right? So many times we have to help the teacher in the class to be explicit about the language. Sometimes, or we say most times it's actually linked to the concept. So for example, to multiply a number by 10, I'm not just adding a 0. So 12 times 10 isn't just, a 1, 2, and a 0, because 12 times 10 is 120, because it is 10 times bigger, So like those kind of things, at some point, I don't know when it became almost like it's just infused, like I think it's so simple. Obviously, I mean, I don't want to make the educators or subject advisors feel like I'm belittling them. I don't want to, but when you see it on the ground, often, time after time, then you realize, actually, that has to be addressed. And so, that times 10 means it's 10 times bigger. Or if you divide by 10, it's 10 times smaller. Some simple things like that, And so like what we've done, I know in the first 5 years of Prof. Hamza's chair, a lot of being specific in how you speak, that played a huge role.
Yeah, absolutely. And I joined Philip, and it's a lovely example. So thank you so much. So Samantha, Dr. Morrison, on behalf of the Centre, and I'm sure as well as the audience, thank you so much for joining us today. We've had some wonderful engagement, and it's been lovely to have sort of some maths education research looked at. It's something that we haven't featured on our seminars for, well, not since I've worked for the Centre, so it's truly been absolutely wonderful. So thank you very much, and yeah, it's been really lovely to host you. Thank you for joining us.
Thank you for having me, being here.
Thank you, and thank you very much to our audience for joining us and all those who raised questions.